Hello everyone. Today let's discuss about our project Code Genie. Let's start with major takeaways from this phase. First, I learned how to integrate a large language model directly into developers tool like VS Code, which required the working both backend and extension environments. I also picked up fast API and WebView integration, which were completely new to me. These were essential to bridge the front end and backend efficiently. Another key skill I developed was prompt engineering, learning how to craft prompts that consistently deliver useful and clean outputs, especially for tasks like debugging and explaining code. Finally, improving user feedback mechanism and error handling help create a much smoother and more reliable user experience inside the extension. Tech stack. In front end, we are using VS Code extension, which is widely used for creating extensions for smooth and native IDE experience. Backend. In backend, we are using fast API in Python is lightweight and async. We can use asynchronous function and Y is used for Hugging Face models. Model. We are using DeepSeek Coder, which is tailored for code generation tasks and runs locally in SQL. Communication is done through actions and REST APIs between extensions and backend. For clean and fast, it is clean and fast and easy to debug. Architecture changes. Initially, I used Olama with DeepSeek model, but I found it depending on internet access and external APIs. So I shifted to fully locally set up using fast API and locally hosted model. This simplified the architecture and gave me full control over privacy performance and customer requirements. And this is our architecture diagram. Here, first the user communicates through VS Code and sends the input, and this input makes an HTTP request to AxiOS, and that request is forwarded to Fast API, which sends the request to DeepSeek Coder, and that will undergo pre-processing, embedding, attention, decoding, and pre-processing, and the refined code output will be sent to extension, and the output would be displayed to user. And this is our architecture diagram. Next, the alternative models consider GPT 3.5 for great, but cloud only and expensive. CodeGen 2 was powerful, but couldn't run locally. Star Coder was interesting, but too heavy for deployment of system. Why we choose DeepSeek Coder? Because it's best. It's really for code task, performs well on CPU and supports offline usage, and it is easy to run reliable output and get entire workflow private and fast. Next, let me explain the code of server.py. First, here we can see the first line is from Fast API, import Fast API, which imports the Fast API from Web Framework. And here we are importing base model to define structure and type validation for request data. And here we are importing auto model for casual LLMs, imports Hugging Face class to load casual models and its tokenizers. Importing touch, PyTorch is used to handle tensors operations and model inference. Here, the OS is used to access environment variables like model path, and load.env loads the environment variable from env file. Here, app is equal to fast API, initialize the Fast API app, class request model, base model. Here we are taking two user inputs, one is string and another one is max min token. String is the text input from user and max token is defaultly given as 1024. The model will be taken from .env file and device is CPU as we are using CPU. Here we're checking login for model loading, and here the tokenizer from specified directory. Here it loads the pre-trained casual model, uses half of the, we use float 16 because it uses half of the question to save memory. And here we are forcing device to use the CPU. And this print statement confirms the model is ready. And this is an endpoint, post endpoint generate that accepts JSON payload following request. Here the input is tokenized the prompt, converts into PyTorch tensors, then sends them to specified device. Here we disable gradient tracking to speed up the inference and reduce the memory layers as we are not using a GPU. And these output model generate will generate the text using the model. And it here maximum tokens limits on generated output length. Do sample false makes the generation deterministic, not creative. EOS and token ID defines the generation should stop. Completion tokenizer decode. This decodes the generated token ID back into human readable text. Clean output completion replace this line, removes the original prompt from the generated text and returns only the new code. And return completion clean output sends the response to JSON object with generated completion. Run, and here its name is equal to name. This whole code runs only if executed directly. This block runs only if script is executed directly. Starts server PM. Now let's go to extension. Here, first three lines, the VS Code is used for extension development and AxiOS for making HTTP post requests to your local fast API backend, and FS for reading WebView HTML. Let's let save editor VS Code text editor undefined and let current string undefined tracks the currently active editor and its programming language. The activate function is called when it is activated or when it's first used. VS Code only change active text. It listens for when user switches between open editor tabs, and if editor is not null, then it is saved to save editor. And this on registering command, the user can invoke the web view. Here, the constant panel, the web create web view panel is created. Creates a side panel where AI suggestions will be shown. JS is enabled for interactivity. This loads the get web view content. This loads the HTML content for web view. On did receive message handles the message sent from web view. Constant select save editor selection. Gets currently selected text in editor. Fetch suggestion. If fetch suggestion command is equal to fetch suggestion, handles the suggestion button. If we click the suggestion button, then it will enter into this loop. And here we are writing a prompt hard coded so that the prompt is very nice for the AI to generate good output. And this is what is prompt engineering. And here the response, here it sends the prompt to your fast API model, and in function extract code back, it safely extracts only the code part from model responses. And if it is debug option, then it will do the debug operation and respectively explanation and insertion. Now let's go to demo. Now we have opened extension by pressing Fn and Fs. Now let's open our web view by pressing Ctrl+Shift+P. Ctrl+Shift+P. And this is our AI extension. Here the web view will be open. Let's try to get the suggestion for a Fibonacci series. And here we are not specifying the language, as our extension can take language on its own depending upon the file. Now let's get suggestion. Now this is going to take some time. Here the extension gave the suggested code, and now we can insert it by using insert button, as we can see here. And we can even ask the extension to explain it. And we can even ask the code to explain it by pressing explain button. Now this is going to take some time. Here we can see the explanation given by the code, and this is the explanation for the given code by extension. And we can even debug it. First, let us remove this and ask it to debug the code. Select the debug button and execute it. And now this is going to take some time. Here we can see after debugging, the extension gave an output that it has a logical error. As we have removed the return for Fibonacci series, it told that and gave the corrected code. And these are the four main features of my extension. And we can even change the color of the web view. Either it can be dark like this or even light like this. And that's it. This is the term of the project. Milestone 1 goals and what I have achieved. Absolutely, yes. I have achieved all my goals from Milestone. The extension is now fully functional as we have seen before. In VS Code, you can generate code, debug it, and even ask model to explain snippets. Everything runs locally with real-time interaction via webview. So yeah, Milestone goals are fully completed. Future enhancements. Looking ahead, I have some exciting improvements in mind. First, I want to add testing and execution of generated code. Second, allow users to customize how the model responds, like choosing verbosity or tone. Third, adding logging and usage analytics will help tailor and tool to a real-world feedback. And lastly, I plan to expand and support to JetBrains IDE like IntelliJ and PyCharm to reach more developers. Right now, the whole stack runs locally, fast API server, the backend and model runs on CPU, no GPU or cloud needed. This ensures full privacy, zero API cost, and low latency performance. In future, I may deploy it in AWS ES to scale it. Thank you. That wraps my Milestone 2 presentation. Thanks for listening.